So, it isn't what you know, it's what ain't so. So, you know, you run off the cliff like a Wile E. Coyote, and as long as he doesn't look down, he'll hang in there, and he looks down, oops, there's nothing under me, and then he falls into that. That was what little cartoon thing's for. So here's some ideas here. The assumptions you're making in your business, make them explicit, and look at the trends in those assumptions. You know, the trend is, you know, disks are going to be here forever. Oh, there's SSD things, those are always going to be too expensive. That's an invalid assumption. You know, SSD is now only twice the price of disk on AWS. It's 10 cents a gigabyte month instead of 5 for attached disk on EBS. That's getting pretty close, but you get 10 times the IOPS for twice the price on capacity. So the price difference is getting pretty low. Eventually it'll be cheaper, I think, you know, give it another few years. Listen to people who aren't your customers. So the problem with big companies is they tend to listen to their customers, and that's where the money's coming from, and they ignore the fact that there's all these people who aren't their customers. Like if you look right now, let's say, take Docker as an example and compare that to VMware. And it's not really quite the same thing, but they're containers that are used for deploying stuff. And VMware looks at all their dollars coming in and saying, you know, we have 99.9% of this market, and Docker, how much revenue is Docker getting right now? It's basically zero, right? Okay, so we're safe because we have all the money, right? That's a trailing indicator of the market. If you look at what's actually happening with Docker, the developer enthusiasm and adoption is off the charts, right? So actually in terms of developer attention span, it's 99.9% Docker, right? So then you look at that. So what's going to happen in the next year or so? It will turn into some money. It may never be as much revenue as VMware has, but it's going to take over the market. And if you have something that's 1% of your cost that's moving in your market, then at the time when you still have 90% of the dollars, you only have 10% of the market left. And that's when you see this sudden collapse that big companies have run into. So follow developer adoption, not IT spend. If you see somebody saying this market, blah, 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 dollar share, then you know they're looking backwards in time. They're not looking at what's going to happen next. And then you want to look at this evolution, products to service to utilities. I spent a long time working for Sun Microsystems, and I cared about Spark chips, and I cared about Solaris and all those things. And some of you maybe got my Solaris performance tuning book that I wrote 15 years ago. I no longer care about any of that stuff. I care about web scale APIs. How you implement it is just uninteresting. It's now utility level, low level stuff, right? The operating system, I barely have to think about. So how do we get there? I'm going to spend some time now talking about some more sort of technical things rather than the business side of this. First of all, if you're in a company and you think like, my company is all old and slow and we can't get there from here and we don't think about this, then this is a great book. This is actually a novel. It's a novel about DevOps. It's a novel about a company that's about to go out of business because they don't know how to do IT. So you give this to as many managers as you can find in your company, and if you read it, it's really a horror story. It opens with a guy driving to work. I think he's a manager in ops, and on his way to work he gets a phone call saying, okay, your manager, the director of ops, and the VP of ops and the CIO both just quit. Come and see the CEO when you get to work. By the way, we've corrupted our payroll run, and Wi-Fi's down in the whole site, the whole company. And the CEO gives him the job of being the new guy in charge of ops to go fix all this stuff. And if they don't fix it soon, they're going to outsource their entire development and operations and everything to just contract everything out and decide that that company does not know how to do computing, right? So that's the beginning. Then it gets worse and worse and worse, and more stuff goes wrong. About halfway through the book, they start using DevOps and things, and it starts to get better. Of course, there's a happy ending. But it's pretty much anything you've ever seen go wrong in a company is in this book somewhere. And so I have a quote on the back. It's the swamp draining manual for anyone who's up to their neck in alligators. So if you're really deep into a problem space, this book gives you a lot of hints to how to get out. And there was a book called The Goal from years ago, for about 20 years ago. This is actually sort of a tribute to that book. It's a rewrite along the same lines. So if you're doing a bit better than that, once you're out of the swamp, or if you weren't in the swamp, then this is a new book. It's just on the verge of being released. It's being continuously updated, so you can get a digital copy of this book, but it's not quite in print yet. They've only just started making a few batches of it. But this is really, enterprises right now are adopting continuous delivery in DevOps and lean startup at scale. And that is one of the transition points that's happening right now. And a lot of the interesting startups are in this space. So Jez Humble wrote the continuous delivery book. It's one of the ThoughtWorks guys, but this is a really interesting book. All right, so the next thing is this is another disrupting area, that basically the most advanced, scalable, stable code you can get anywhere is actually open source, right? You know, Cassandra is more scalable than Oracle, and pick a big old piece of software, and there is a better open source thing now. And the main vendors that you have for building large-scale, high-quality code now are Twitter, LinkedIn, Google, Netflix, Yahoo, right? Cloudera, whatever. So these are the mainstream applications that people are building companies around now. And the days when you went to IBM or HP or Oracle or Sun to get your code to do something have passed by. So GitHub is a developer's online resume. If you're going to hire a developer, say, what's your GitHub ID? Go read their code. You don't need to have them scribbling on a whiteboard. You can see what they do, right? And then the developer will say, okay, what's your company's GitHub repo, and what are you supporting, and how many of your developers are you encouraging, and what have you put out? So think of your company as generating interesting things. And you're seeing more and more people now, more and more companies now using GitHub and using open source as a competitive strategic advantage. Netflix has like 46 projects in open source. Facebook did 62 so far this year. 62 different open source projects since in 2014. It's an explosion. So the problem here is actually, I call it, what's the right phrase for it? It's basically, instead of technical debt, it's technical indigestion. Right? You can't actually keep up with all this stuff. There's too much out there. So you build these platforms, you create an ecosystem around the platform. I was working for the last few years trying to create an ecosystem around Netflix OSS. We have a few large companies using it, and a few, quite a reasonable number of people actually. And the other thing is this control versus ubiquity thing. Apache license is good. You don't have as much control, but you'll get much stronger adoption. And if you get strong adoption, people won't want to fork the code. So it becomes a carrot rather than a stick approach, right? You don't want to say, no, you can't fork my code. So if you put too much control around it, like the worst one is AGPL. If you see some code that's AGPL, that means they really didn't want to do open source in the first place. They was like forced to do it, and they really, you're tightly controlling it. And most people won't use AGPL code, in my experience. So, all right. And then this is the cloud native stuff that Netflix did. Basically, you build stateless microservices as a layer that you can rapidly deploy, and then you build a sort of Cassandra or whatever based storage layer, and you keep those two very separate. You have immutable code with instant rollback. Just switch the traffic around. If you get the new version doesn't work, the old version is still running, so you can switch traffic back to it. It's a very powerful technique. You can do it in seconds. Capacity and deployment updates are automated and auto-scaled, so if your new code is half as efficient as the old code, you just end up with twice as many machines when it finishes launching itself. And it just keeps going. You can go, you know what, I don't care that it's twice as many machines this week, but if it turns out to be that's a big expense, maybe you go and work on performance tuning, and next week it's a quarter as many machines. You get to pick that later. You distribute automatically across availability zones and regions. So that's a simple just difference in the API calls you're making to the cloud. So building highly available, globally distributed applications is actually trivial now. And then this sort of denormalized single function NoSQL data stores. The back end that Netflix has is almost 100 different Cassandra clusters, distinct clusters that don't talk to each other. So this is the total opposite to the typical SQL schema where everything is in one big place and any changes have to be negotiated with all the other developers. But then when your writes get sprinkled across everything, so you have to have things in the background that are checking and keeping stuff in sync. So it's a little bit more complicated to update, but it's much more highly available and scalable. Yeah, and you'll get technical indigestion. So yesterday we have Security Monkey came out. So if you want to build something that monitors all your security groups and all your ACLs and permissions on your S3 buckets, That's what Netflix uses, and if you create an open to the world S3 bucket or one that trusts an AWS account, somebody else's AWS account, it will alert you. And if your security groups are set up to be wide open to the world, it'll alert you. So it's that kind of thing. The team there. I was talking to Dome 9 yesterday. Were the Dome 9 guys here? Maybe. But they have a much more sophisticated product that does something that's, for managing security groups, there's some nice tools for doing it. But this is sort of a very basic thing. It doesn't visualize it. It just gives you some simple controls. And Chaos Monkey is there's a bunch of other stuff in Netflix OSS. Chaos Monkey goes in and kills machines to prove that you can survive machines dying. And the point about building these architectures is that everything is automated and replicated. And you've told Amazon there should be 100 of these machines running, and if it notices there's only 99 left, it starts another one. So if a machine dies, it just goes, oh, restart, right? Bring up a new one. So that was what was baffling people for a few years, but a lot of people are now doing this. So this is microservices. This is my definition. People say, isn't it just SOA? Well, it's a little bit different because SOA, I think, was more tightly coupled. What you're really trying to do here is build a loosely coupled service-oriented architecture, and you have this idea of a bounded context. And the bounded context gives you the ability to have API calls and not worry about stuff outside that context. If you're building a monolithic app, you really have to have everybody understand everything that's in that app. So anybody could debug any part of it. And that's to do that really effectively. That's kind of the Etsy model. They have 100 developers that any of those developers can fix anything in their app. And that's a monolithic deploy. They get some different benefits from doing monolithic, but it gets harder and harder to scale as you get bigger. And the transition is probably, somewhere at sort of 50 to 100 developers on a monolithic app is where you're really starting to run into issues. Netflix, as we got beyond 100, went, we have to break this up. Netflix is several hundred developers. So this is the difference between monolithic and microservices. So instead of sort of saying, I want to be on this train, you have your own build. You can deploy anytime you want. Instead of everyone running it, you run your own microservice. There's no waiting, no meetings. You do an API call to update prod instead of going into a chat session with the ops guys. You don't need to learn the deploy process. It's automated. It's immutable. You got lots of unlimited concurrent versions running at once. You can do hundreds of independent updates a day if you want. You can roll back in seconds. And the definition of done used to be I've given it to QA. Like if you're a developer, have I done my code? Okay, I've given it to QA, I'm done. Then it became, okay, I've gone past test. And then it became, okay, it's running in production. I'm done, right? But now it's not. Done means you've taken your code out of production. If you have some code running in production, you're not done. You're on the hook for anything going wrong with it. And that's the new definition of done in this world. So it's a real incentive to remove old code from production in case it breaks and somebody calls you, right? Which is another interest, tighten that feedback loop. It's good. So the way you separate these concerns is, Conway's law says that the code will resemble the organization of the structure of the organization that built that code, right? That idea has been around for a while. So what you do is you create an organization that maps the structure you want to have. So each team will form a group of microservices, and each developer will create their own set of microservices over time. And each developer, typically, sometimes you get teams of developers for some of the front-end services that tend to be a bit more sophisticated or complicated, but most services you want to break down into single function things, like a single verb, single REST verb is a good basis for a microservice. But the domain-driven, if you look at domain-driven design book, then it's got a good definitions of how to get the sizing right. You want to use a container, you can use Tomcat as a container or an AMI or Docker, it doesn't really matter, but your deploys go in a container. And this is one reason Docker is getting interesting. A lot of people, Docker themselves talk about microservice architectures being one of the reasons why Docker is catching on. And then this idea of stateless business logic. If you have a machine in production and it has a name and you care whether it's down or not, it's like having a pet at home, right? You care whether your cat's alive and it has a name, right? Because it's your cat, right? I have a cat at home. If I have a field full of cows that I milk every day to get milk, right? Any individual cow there has a number, right? I don't care if one of them dies one day. If I get short on cows, I'll buy some more cows and restock that field, right? So that is the difference between cattle and pets, right? Every service that is launched in this environment is a field full of cattle, right? There's a name for the field and you're getting something out of that collection of things, but any one machine in that collection can die and you don't care, right? If you've got enough personally invested state in a machine that you customized it, that, you know, right, then it's a pet. So watch out for pets. Avoid them. And then the data layer. So I talked about Chaos Monkey deleting machines. Netflix uses Chaos Monkey to delete Cassandra instances that have disks within them, and you lose state when you do that. So they're actually killing stateful instances. But there's 3 copies of all the state, and when you kill one of them, it automatically replaces it with a new, fresh machine, copies the data off its 2 buddies, and resolves itself, basically. So they're actively introducing failures like that into their system every day to make sure that, you know, they have several thousand Cassandra machines, but they're doing it to make sure that Cassandra will always auto-heal itself. So when a machine dies for some other reason at middle of the night, it replaces itself, and that never goes wrong because they test it every day. So that's the mentality, and that's taking it a bit beyond where most people okay, I kind of get you deleting the stateless business logic, but deleting the machines with the disks in it, it's not great. So don't try that with MySQL. But you typically with MySQL or Mongo use attached storage, and you delete the instance and remount the disks, and that's kind of, it's a more of a master-slave pattern. But with Cassandra, it's already doing the replication. It has all of the repair logic built into it, and you know, there's a few other databases that you can do that with. Okay, so development architecture. You've got all these services. How do you talk to a service? Right? It's got a REST API. Do you talk directly to the REST API? Well, it depends what level you're writing your code in. If you're writing sort of a Node app and everything's in JSON, then or Python probably, you can just consume a JSON object you get back directly in the code. There's not really any need for a library there. But if you've got, you know, more sophisticated code and you want to do some more isolation in there, and the way Netflix tends to operate is that everything's written in Java, and one of the things you do is if you have an API, you have to write some code to talk to it. And then so it's the best way I think that's. So if you started off not building a client library, somebody else will build one for you. And then they'll share it with their friends. And then eventually there's this code you didn't write out there that talks to your service that doesn't work very well because it doesn't really understand the serialization and the error handling and everything the way it needed to. So the best thing to do is to own it from the beginning. And you can see some of this in products. One of the reasons MongoDB is very, very good for developer adoption is that they owned their client library from the start. They own client libraries that are high quality for every language and every ecosystem. And that meant that their developer adoption was very, very fast. But Cassandra had contributed code in the client libraries for a long time. And a lot of the problems with developers getting into Cassandra was that, you know, which of the 4 or 5 different ways of talking to Cassandra do I pick from Java, right? So it wasn't that great. So what the DataStax have been doing more recently is fixing the client library space, but they've had to patch that in later. You know, operationally, Cassandra works better than Mongo once you try and scale it, but from a developer agility point of view, you know, Mongo's better to get started with. And that comes sort of out of this whole idea of the client libraries. So best thing is to own your libraries from the start for the core languages you need to support. You also have to worry because you've got this network of services calling each other. What happens when something fails? Does the error propagate back up and block everything? So you want to use some multi-threaded, non-blocking I/O. And the reactive model is a new thing. So RX is a new pattern came out of Microsoft research in the C# space. And then RX Java was developed initially at Netflix, and more people are contributing to this now as the Java version of RX. It's observable pattern stuff. If you're a developer and you're trying to build highly resilient code, this is actually a fairly new pattern for doing it that works extremely well. And then you want to build circuit breakers. So if there's a service out there that's broken that you're trying to call, you don't want to keep calling it. You want to know it's broken and stop calling it for a while and just call every now and again to check. So that's like a circuit breaker in an electrical system. Hystrix and Turbine, and then there's Latency Monkey and Ribbon. Those are the Netflix projects that implement all of these bits and pieces. And if you're more into Scala than Java, for example, then Finagle and Zipkin and Twitter's ecosystem is sort of an equivalent thing, but more oriented around data center than cloud, and more oriented around Scala than Java. So there's a number of, I've seen quite a few people adopting the Twitter ecosystem for this as well. If you've got an existing schema, big data set, you need to break that up as well. So there's a nice book called Refactoring Databases, and you can use Schema Spy to look at what's going on in there. And then what you're basically doing is every materialized view or table that a particular service depends upon, you turn that into its own backend. Right, so you end up with lots and lots of data stores, where each data store holds effectively one materialized view or one table's worth of information, and you don't try, and then you do joins in the application code level. The Stash is another Netflix project which has an abstraction layer which will talk to both MySQL and Cassandra and put an HTTP, REST-based data access layer in front of it. So it's basically just a prototype data access layer that knows how to talk to Cassandra with a bunch of nice, useful patterns, and it knows how to talk to MySQL. So if you're trying to convert from MySQL to Cassandra, you can put Stash in front of it and then do the gradual migration. But you're converting your clients to use the HTTP interface to the data rather than go all the way into SQL code. So the key thing here is that when you finish this process, there's no SQL code embedded in your business logic. It's REST calls to services. And all of the SQL code is deep in the data access layer only. And then there's the whole idea of whether you need to be more consistent or more available. And there's no such thing as a consistent distributed system. That's actually kind of relativity and Einstein kind of problem. Like once you separate two things by any distance, the speed of light means that you actually can't know whether they're consistent or not. So most computer systems that say they're consistent, they're just fudging it to some degree, right? I have a physics background, so rather than computer science, so anyway. So if you can get over that, so you can fake consistency up to some level, but what you're typically doing is at some point, in order to keep it consistent, you have to say, no, I cannot consistently do this operation, you have to stop doing it. So the availability is always going to be hurt. And that's, explain the CAP theorem is a good interview question for distributed systems developers. If you're using a common database in a distributed manner, you should go look at the Jepsen, effectively torture tests. AFIR is the Twitter handle of the guy that's been taking all of the systems like Mongo and Cassandra and Redis and Elasticsearch and everything like that, and then he does partition testing to see what happens, and they normally break horribly. And he's been helping people debug their distributed systems. Okay, so you're trying to get from A to B. You're trying to take your old monolithic machine into this new world, or you're trying to go from data center to cloud. And the product managers are throwing new requirements out, and you don't have time to do the transition. So how do you deal with that? And there's really three strategies here. One is to say, this new feature will be ready, new features will come in quicker once we've done this transition to microservices. Another one you can say is, I'm only going to implement this new feature in the new system, so you better let me finish building it. For Netflix, that was the internationalization libraries. The old system, monolithic data center system, was US only, English only, and had no ability to internationalize. And when Netflix did the cloud migration, they internationalized everything as part of that transition. And they said, okay, you want to do French in Canada, you want to do Spanish in Latin America, okay, we're going to only do that in the cloud version. That code will never run in the data center. So that was the stick. And then the shiny object was, go play with PlayStation user interfaces instead of the website for a few months so that we can transition the website over. So we'll talk a bit about monitoring and then wrap up. So these microservices have a high rate of change, floods of new instances, And so if you've got a typical monitoring system that says, hey, I see a new machine and this new IP address, and it's going to sit there for 3 years because I just bought it and I'm going to depreciate it. It's going to sit in my data center and it's not going to move. That assumption doesn't work anymore because in cloud, IP addresses come and go in a few hours quite often. And then you say, well, I'm going to build up my alert thresholds over time and automatically figure stuff out, but my machine only existed for an hour. You know, how does that relate to the previous version of it? So there's a whole bunch of baselining and threshold analysis that's a problem, because basically everything is unusual all the time. And then it's just hard to aggregate these views. And then if you have a hand-tweak monitoring tool, it just can't keep up. It takes too long to edit your agile configuration or whatever it is to keep this stuff going. And then these end-to-end request flows across your system become really important. So you need to track them all the way through. So the Netflix libraries for doing this, every time they make a REST call between two services, they throw a GUID in the header, which is uniquely identifies that transaction. And then there's a sub-transaction. So you can actually map the flow and the tree of requests from hitting a front-end service that flows out into the system. You can collect all the logs with these tags, and then you can do a percentage as well. You can do a consistent percentage, like by customer ID. 1% of customers, but the same 1% all the time will be logged by the system. So that gives you an ability to draw this map that shows what's actually happening in the system. App Dynamics has a similar technique, which they direct inject into your Java code, so you don't need to do it explicitly. There are a few other ways of doing that. The libraries that Twitter have are instrumented in the same way. I've got a diagram soon. So this is from a guild group presentation. So how many microservices should you have was the question. They said, well, we just kept working on it and we ended up with 450 and increasing. I'm not sure if they have too many or not enough, but basically if every new thing you build is a microservice, you end up with hundreds of them. And that's not a problem. It just becomes, you just need a tool that can manage hundreds of things. This is their view. This is actually from the Boundary app showing the calls between some of their microservices. But the thing is, they said they had 450 and there's only 12 on this diagram. So this is actually a very simplified view. And this is what it really looks like. This is an App Dynamics view of Netflix from a long time ago. And you can't even draw it now. Netflix, in the end, stopped using App Dynamics because it couldn't cope. It just outgrew the ability to visualize or run at all, basically. App Dynamics works great up to probably 5,000–10,000 nodes. Netflix is running sort of 20 to 30,000, and it just became too much. And then that's the Twitter using a nice D3 chord view. But the things you can't read here are the names of services. And this is the traffic between them. Groupon, I saw a diagram. I couldn't find it online, but there is almost exactly the same diagram for Groupon. Lots and lots of people now, this is the architecture diagram. So don't try and draw the architecture diagram because it's not helpful anymore. There's too many versions of things. So each of these green things is a service, an icon, and then the lines between them just get too messy. So the implications here, you're making smaller, more frequent changes. Any individual change is more likely to be broken, and changes are normally deployed by developers, use feature flags to enable code. So instant detection and rollback matters much more. So from a tooling point of view, it's really important to notice something broke immediately. So I'm going to do a quick run through here. If you have 1-minute updates in your code, in your monitoring system, and something broke at a particular point, at 2 minutes, 20 seconds here, you flipped a switch and turned on, everybody now has access to your new feature, right? And it just broke. So the average of 40 seconds of failed and 20 seconds of working wasn't high enough to trigger an error. So 1 minute later, it finally says, the agent on the machine says, okay, there's a problem here. There's a high error rate, and I'm going to send that to the central monitoring service. Another minute later, it arrives at the monitoring system, and then that has to look at a few data points before it believes that the data is actually correct, because you don't want to trigger off of glitches. You actually put it on a graph eventually, and then maybe 10 minutes later or 8 minutes later, you have enough data to say, you know what I just did broke the machine. But you've just gone and got your coffee, and you weren't paying any attention, you're worrying about something else. 10 minutes is too long for somebody to stare at a graph waiting for something to happen, right? So you push the wrong button, oops, revert, let's go back, let's turn it back to the old code, and so you push the button and you go and get another cup of coffee while you wait 10 minutes to see whether that fixed it. You get a half-hour outage or a 20-minute outage. But if you could do that in seconds, it would be much nicer. So this is what the same thing looks like if you do it in seconds. So here's the breakage. 1 second later it noticed that you've got a failure, and the agent says, yeah, you've definitely got a failure. It sent it to the monitoring system a second or two later, and then you process it, you put it on a graph, and you're a few seconds in here. And then you got enough data points here. So like 5-10 seconds after you actually push the button, you go, whoops, let's switch it back again, and you're back at it. Sorry. So the idea here is you can have an outage that lasts 10 seconds, or you can have an outage that lasts 10, 20 minutes. And the point about having it be within that 10 seconds is you're still looking at it before you go and get your coffee. This is a tool Netflix built that shows you about the last 30 seconds of what happens on a machine. This is Hystrix, and you get an outage, it looks like this, it goes red, and you get a percentage error rate, and a circuit breaker basically goes and says, this is an upstream service saying, this new thing you did, it broke. So the circuit breaker flips, and the circuit breaker alerts come in. This works by connecting your web browser directly to the front end, the API server, or the machine that's consuming services, and that's where the circuit breakers live. And when you get bad code downstream of it, you get immediate notification. So this is pushing JSON over a WebSocket directly to your browser. There's no intervening system. So that's low as latency as it could be. And the turbine is a thing for aggregating. So if I've got 500 machines, you can take all of these sort of WebSocket-based flows and put them into Turbine, which combines them into a single browser view. So you can see hundreds of machines at once. But there's no intervening storage. This is a direct, you sort of only turn this on when you're actually about to flick a switch and you want to see what's really happening. Okay. So there are a few tools that actually do this as a SaaS application. So they collect data off machines on a 1-second interval and put it into a back-end service and can tell you it's stuff that's broken. Vivid Cortex is actually one that looks at MySQL servers, basically, and tells you what's going on, and it can see 1 second sort of order of glitches in the system. So it's actually a Battery Ventures investment. It's a new product launched this year. Boundary's been around for a few years, but they have 1 second monitoring as well. More network focused in terms of what they do. So the microservices thing is really about separation of concerns and bounded contexts. You want to only have to deeply understand stuff that's in your context, and you can have high trust within that context, and you don't trust anything else outside it, and the separation is via APIs. So this is the same as programming on the internet. If you've ever written a web application or a mobile application, you're talking to maybe like the Google Maps API, and you've got a Facebook API, and some other API, and some monitoring API, and some crash monitoring API, and all these external companies, and they're outside your trust zone, and they are outside your bounded context, but you figure out how to integrate to them. So treat the rest of your organization in that same way. So that's basically it. So it's a pattern that's familiar, but you don't usually use it internally at companies, at large companies. All right, so questions. Battery Ventures there, my blog. We have some blog posts that are nicely written up here. I have more scruffy blog posts at my blog. These slides are a very similar set, are on SlideShare/Adrian Cockcroft. Some of these slides, and there are videos online from Monitorama. Go to Chicago, I did the opening keynote there. That was the first time I used this basic slide deck. So I think that video may be up soon. I was at QCon. I'm going to be in Denmark in September. There's a DevOps Enterprise Summit. So if anyone is an enterprise level company trying to adopt DevOps, there is a new conference for that particular case. I'm on the program committee, and that's going to be in San Francisco in October. And after that, I'm planning to come back here. We're looking at, hopefully I'm going to be here for the Journey conference, and immediately after that is the Go to Berlin conference. So I'll do another European trip then. So hopefully I'll see you guys then.